Hello there and welcome to my workshop. Today's video is going to be putting the electronic package together for Katie, the CNC lathe conversion. So I have a short 240 mains lead and I'm going to connect it up now to our power source. So we have, now in your region in the world the colors may be different, but this is Australia and brown is live, green or green and yellow is earth, and blue is neutral. So put the earth in first, as is at that end. Neutral or negative. Live. So that is now ready. If you are not sure about any of the wiring that I'm showing you, and I might point out at this point, this is the way I'm doing it, but if you are not sure, seek professional advice. In the past when I've done these builds, I have found that the motors can actually do some strange things, and they can actually move on their own without being commanded to then, just because the earth hasn't been connected, you know, the ground hasn't been connected, the full circuit then. So the board actually needs a separate earth, these need a separate earth as well, which they get through the board on this terminal here. If I fetch this up to the camera might pick that up. I'm pointing with my finger there. That symbol there is for ground. So we actually need to give these a ground as well. Okay. So the next thing I am doing is to give these drivers a positive and negative DC voltage feed from the power supply. So you need thicker gauge cable. Okay, good heavy stout cable. This is the type of cable that you'd get from a automotive outlet. So what I do is just strip the insulation off about half an inch or a little bit less. So, and then twine the wires. It's not really necessary to tin these, they're big enough to not cause any problems. So I'll just continue stripping these off and then we'll connect them up. Okay, I'm just temporarily wiring this up so I can bench test this before I put it inside the case. So here we have our 2 positive and 2 negative coming from the power supply. So we'll put one of the negatives in first, which goes in here, sign there for negative, and this side is the motor side. This side is the information side. Should we trim that a bit shorter? I would do the same with the other one. Now I've just come against a problem. I can't actually get that screwdriver in there to do that up, so it's very simply you just catch out of the plug gently and pull it out. So then you can connect the wires on. Just remember to orientate the plug in the same direction as what it came off, and so then mimic where you put the wires in. So negative. So the next job we're going to do is we're going to wire in the stepper motors into our drivers, and for that we'll need the wiring diagram that comes with the motors. We'll also need the wiring diagram that comes with the driver, and it's very, very simple actually. But at this stage I would like to put a big shout out there and a thank you to my patrons. Thank you guys. Without your assistance this wouldn't be possible. And for those of you who would be interested, please go along to my Patron page. I would be very grateful. This is another thing I like about this company too, and this is the company that supplies direct from China, Hong Kong actually, is, you know, they're not skimpy with the length of the wire either, that they actually give you, with the motor is over half a meter, half a yard, which is very good. And they are, even the paint job on them is excellent. Okay, so there's no real great mystery with stepper motors and their wiring. In this case we have a 4 lead or 4 cable stepper motor, which is the average type. You can get 6 or 8. So in our case they provide a little diagram showing you, okay, so the blue and the red is connected on one coil, and the green and the black is connected on the second coil. Now if we go to our diagram for our stepper driver, these are multiple cables, as in 8 cable and what have you. As you see here, 8 lead, and it tells you how to pair them up to make 4, which is what you would do. In our case, we have a simple 4 cable stepper motor. So if you compare the two, you can actually work out that very easily that, okay, these are the terminals on the stepper driver, which is B minus, B plus, A minus, A plus, and you match it up with this one. So the blue would be this one, which would be minus. The red would be this one, which is B plus. The green, A minus. The black, A plus. It's very simple. It's not really complex at all. So that is how we'll wire them up. So, blue is B minus, red is B plus, green is A minus, and black is A plus. So now I'll connect the other motor up for the other side. Okay, Okay, so we have our motors now wired up to our drivers. So the next job now is to wire our Mach 3 board to our drivers, to give the drivers information. Now, it's really not complex, and it's probably easier if I show you what on here rather than try and show you on the actual object. So what we need to do is take a 5 volt off pin number 2, and we need to feed it into pulse or pull plus 5 volts is written on there, and also on the direction plus 5 volts. So what we do, we just take one lead, connect it into the 5 volt terminal, connect one end of the lead into the 5 volt direction plus, then loop it over into the 5 volt step or pull plus, and then take a lead off that and loop it over to this driver and do the same and loop it into the terminals over there. So just one lead and you just loop it into the drivers, and I'll show you how to do that. Okay, so that's what that 5 volt supply wire looks like. 2 short ones, an intermediate one and a longer one. And I'll show you how to connect that up. I've just connected into the second terminal there, which is the 5 volts supply from the board. 5 volt supply from the board, which is the second one along on there. And we've looped it into the pull or step plus 5 volt, looped it over into the direction plus 5 volt, and then looped it over to supply 5 volt to the other driver for the step and direction. So that's the first part done. The second part now, and the last part actually, for this little bit of wiring, is the step and direction for X and the step and direction for Z. We're only using the 2 axes, so we'll just connect these up now. Okay, hopefully you can see in there I have a blue and a yellow lead, an orange and a brown one, connected into the step and direction of the X and the Z. It's a little bit difficult to see, so I've determined that this one here is going to be the Z and this one's going to be the X because that's the way they are on the board. So we're going to connect them up. First of all, we're going to connect up the step or pull. Sometimes they're written step on here, sometimes they're written pull. Means the same thing. So we're going to put that one in there. And we're going to do the same on this one. Basically, that's wired up. Okay, so far so good. Now the next bit, a lot of people find quite complicated, but it's really fairly easy, if you're methodical about it. And that is setting the dip switches for your stepper motors. Okay, so you first of all have to go to the specification sheet of your motor, and to see on here, okay, so we want they're 3.1 Newton meters of holding torque, so they're very powerful for this size. They draw a maximum of 3.5 amps. Okay, and the rest is okay. We don't need to. So all the figures here we need, or the only figure we really need here, is the 3.5 amps. Okay, so then you go to your little booklet, and you come to this table here, the dip switch table. Now, each sequence of these switches, okay, sets the driver up to deliver the correct amount of steps for the motor. Now that's going to determine whether you have a reduction drive, in other words a belt of 2-to-1 ratio or whatever. We have direct drive. Alright, so in our case we would want to set, and I would recommend that you would set the micro steps to 4. Now if you was, because you want the extra torque, okay, if you had a reduction, in other words you had a drive pulley on the end of that going to say 2-to-1 or 3-to-1, then you would you'd want the motor to turn faster, okay, to make it move, you know, the sort of make the gantry and the what have you, or the tails, the carriage, in this case on the lathe, to move at a decent speed. Then you would set it to 16 steps per micro steps. So in our case we want to set for 4. So that's the first part of this. So let me see. Micro step in resolution. That's what we're looking at. So for 4, we're looking at on, off, on. Alright? So that's switch number 5. Tell you what, we're going to start with the current first. Okay. So we're going to start with switch number 1 and work our way across. Now, so we want, let me see here, well, peak current and RMS, in other words running current. I don't want to overload these, the motors at all, so we're going to go midway here. We're going to set it for 2.69 amps RMS, normal running, and 3.76 amps peak. Okay, so that particular one there is dip switch 1 is on, dip switch 2 is off, dip switch 3 is off. So that's what we'll do, we'll set that. So it's off, so it's on, off, off. Okay, I'll try and stay out of the way of the lengths. Okay, so let me just recap. So we want on, off, off. Okay, so that one's already on, so that's number 1. Okay, So we're going to go off, off. So that's on, off, off. So that's that current set. Then we go to switch 4. Can you see that there? It's not blurry. Okay. Switch 4 in the off is half current. Alright, so we want full current. So we're going to switch that one on. One, two, three, four. Oop, bit fiddly. Okay, that one's on. And now we come to micro steps. Okay, now I'm going to set this to 4 micro steps because we have direct drive. If you had a reduction gear, then you would go to 16. Okay, so we're going to go 4. So that's, let me see, 4, that's on, off, on, on. On, off, on, on. So there you go, it's set correctly. Now I'll just set the other one now to match it. Okay, so basically that's enough wiring there to get these stepper motors working. So the next thing I have to do is get a computer over here and hook it up and test it. Okay, so I've got this wired up, we've got power going to it now, we've got USB cable hooked up to the computer, computer's running, Mach 3's up. I've got a red flashing indicator light on the board telling me that the board sees the computer. I have a symbol here that tells me that Mach 3 and the computer sees the board and they're talking to each other. Fine. I've got green light on here, green light on here, green light on there, so there's no wiring problems. Otherwise there'd be one of these red lights on. Motors, everything's hooked up. So what you need to do then is go into config, go to ports and pins, I go to motor outputs and turn on the X and the Z, but turn everything else off. Okay, then you go to the input signals, turn everything off. Okay, everything off, because otherwise you're going to get an error message up on Mach 3 and it won't do a damn thing. So at this stage you don't want any protection as such, because you're not going to run into anything, because you're not physically connected to anything. So there's that. Output signals, just leave that one ticked, and that one, that's fine. Nothing else. Now then, the next thing you need to do is go into motor tuning. Now just to start you off, just to be able to know that you can move the motors. This is not setting them up for a particular distance or anything like that. It's just setting them up so you know that the motors are going to turn at a decent rate so you can see they're turning. Steps per 350. Velocity about 1,000. That's fine. Acceleration 300. Don't worry about the rest of these. Mach 3 will look after that. So you set the two motors X and Z the same. Okay, that. And then pull out the pendant by pressing the tab key on your keyboard, and let's see if they work. X. Oh, press reset first. X working. Both directions. Z working. Both directions. And really it's as simple as that. Providing you have the information on the board, i.e. which pin is what. It's actually written on the boards as far as the step and direction and the supply for 5 volts are. All the others are just numbered. Okay, so you need the specification sheet that gives you the information of what the rest of these are. Now I can tell you that this is information in other words, this will be the this will be the limit switches or probe or things like that, and you just connect into these, whether it's a limit switch or whatever, and then in Mach 3 you tell Mach 3 what pin number they're on the board, and we'll come to that in the future. So at the moment what I want to do with you, if you're following along with this build, is get you to a stage where you have sort of completed on the bench your wiring of your stepper motors, and that your Mach 3 smooth stepper board is talking to your computer and you are able to operate from the computer the motors. So I think we'll call it I think we'll stop this video here now, because all I've got to do now is virtually just screw this into that computer, and I'll just unhook from the main power supply, and then screw it all in, make sure everything's secure in there, and then rewire it back up. And I also have I use aviation plugs. Okay, so these will be in the back of the old computer unit, and these will be connected to the wires that are connected to the motors, and they just simply plug in and they screw in. So these are aviation. Any decent electronics shop or electrical supply shop will carry these. Okay, I'd like to give a big shout out to my patrons who make this possible, and the rest of you for watching. Thank you very much, and if you've liked the video and it's been a help to you, please press like and subscribe to my channel. That's a really good thing to do. And on my channel you'll see things like this, CNC conversions, wood turning, CNC routing, CNC milling, and laser machine operation as well, and the associated programs with all those tooling. So thank you for joining me, and it's bye for now.